Welcome viewers. In this video we will see the solved problem based on the Norton's theorem with the DC circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. The problem is find the voltage across the 15 ohm resistor using the Norton's theorem for this circuit given. So this is the terminal AB. 15 ohm is connected. We need to find current flowing through this 15 ohm resistor. The circuit, we have two voltage source available, 75 voltage, 20 voltage source, and this 60 ohm, 75 ohm, 30 ohm, and this 15 ohm is a load resistance. So this complicated circuit should be converted into Norton's equivalent circuit. The Norton equivalent circuit have short circuit current source, one current source connected in parallel with the R Thevenin. Then how to find the short circuit current? The terminal AB is short circuited. Then current flowing through the terminal AB is nothing but ISC. R Thevenin is nothing but the resistance across the terminal AB by removing the voltage sources. Either voltage or current source. Here only voltage sources are available. We need to remove the voltage source and we need to find what is the equivalent resistance across AB, that is nothing but a R Thevenin. So that this complicated circuit now simplified with one current source parallel with one resistance. This is terminal AB, that is terminal AB with 15 ohm resistor. So after simplified circuit, we can easily calculate the current flowing through this terminal AB because two resistors are available, one current source is there. So by using current divider rule, at this point current will be divided. By using current divider rule, we can easily find the current flowing through the terminal AB, that is nothing but load resistance 15 ohm resistor. So that is the aim of this Norton circuit. Complicated circuit is converted into simplified Norton equivalent circuit. Now we'll see that. $75 voltage is the ideal voltage source. 60 ohm resistor can be removed without altering the performance of the circuit. The resultant circuit is right. So this 75 ohm is available. So we can remove this 60 ohm because it is the 75 ohm is ideal voltage source, right? So voltage is not dropped across 60 ohm resistor. That is the ideal. Normally voltage source in series with the resistor will be connected. In current source parallel with the resistor will be connected. So any resistor connected across the voltage source, we can remove it, right? So 75 voltage is the ideal source. So 60 voltage can be removed without altering the performance of the circuit, right? So after removing, this is the equivalent circuit. Now we need to find first step ISC, short circuit current. The step 1 is to find the short circuit current ISC. That is the terminal A and B is short circuited and we need to find what is the current flowing through the terminal A and B, right? So this resistor is removed and the A and B is short circuited. So by using the loop method, KVL, Kirchhoff's voltage law, we can find the current. So this is the first loop. Current flowing in the first loop is I1. This is the second loop. Current flowing through the second loop is I2. So the I2 is nothing but ISC. Both are same. This I2 is flowing in the second loop. So current flowing through the AB also I2. So I2 is equal to ISC. Both are equal. So we need to find I2. From that we can easily I2. If you calculate I2, that is nothing but ISC. So by using this loop method, we can frame the matrix format. So this is voltage matrix, current matrix, and resistance matrix. V equal to I into R. This resistance matrix is nothing but this is R11, R12, R21, R22. R11 is nothing but resistance available in the first loop. This is the first loop. What are the resistance available? 75 ohm and 30 ohm. So 75 plus 30. R12 and R21 is nothing but the resistance between first loop and second loop. R12 or R21. So this 30 ohm is available between first loop as well as second loop. So minus 30. Other than diagonal, all elements are negative. So minus 30, minus 30. Commonly available between loop 1 and loop 2. Then R22. R22 is the resistance available in the second loop. In the second loop only 30 ohm is available. Right. The current is I1, I2. Current in the first loop I1, second loop I2. Then this voltage. The voltage in the first loop is 75 ohm available and 20 ohm also available. Both are connected in opposite. So 75 minus 20. In second loop, the only 20 voltage source is available, 20. Right. So after simplification, 75 plus 30 is 105, minus 30, minus 30, 30, I1, I2, 75 minus 20, 55, then 20. Right. So this is the form. Now we need to find a delta value. This is nothing but delta. Right. KVL method separate videos are available. Delta equal to 105 minus 30 minus 30 and 30. So we need to find the determinant value. 105 into 30 minus of minus 30 into minus 30. Right. So 105 into 30 is 3150. 30 into 30 is 900. There are 3 negatives available. These 2 negative got cancelled, but this negative will be available. So 3150 minus 900 is 2250. Now we calculate a delta value. Then we go for delta 1 and delta 2. Delta 1 means replace the first column with voltage matrix. Delta 2 is replace the second column with voltage matrix. But here only we need I2 because I2 and ISC both are equal. I1 is not needed. So we need to find only I2 so that we will calculate delta 2 value. Directly we can calculate delta 2 value. No need to go for delta 1. Right. So this is the first column. Second column is replaced by the voltage matrix. 105 minus 30, 55, 20. This is nothing but the second column replaced by the voltage matrix. So 105 into 20 minus 55 into minus 30. So 105 into 20 is 2100. Here two negatives available, so it become positive. 55 into 30 is 1650. So by adding this we got 3750 delta 2. Delta 1 is not needed. So I2 is nothing but ISC is equal to delta 2 divided by delta. So 3750 divided by 2250, that is equal to 1.67 amperes. So the short circuit current in a equivalent circuit, we need short circuit current, that is nothing but 1.67 ampere. So in the second step we need to find the R Thevenin value. R Thevenin. We'll find the R Thevenin value. How to find the R Thevenin value? R Thevenin is nothing but the resistance across A and B. All the sources should be removed. After removing all the sources, we have 75 ohm and 30 ohm. So we need to find the resistance from this end. So the current is flowing through this. At this point current is diverted, so that the 75 and 30 ohm are connected in parallel. 75 and 30 ohm are connected in parallel. So that R Thevenin equal to RAB equal to R1 into R2 divided by R1 plus R2. That is 75 into 30 divided by 75 plus 30. 2250 divided by 105, that is equal to 21.43 ohm. So R Thevenin, that is the resistance across RAB, is 21.43. So now we calculated short circuit current as well as R Thevenin, so that we can draw the Thevenin equivalent circuit, then we can calculate the load current. So the step 3 is to draw the Norton's equivalent circuit. So this is the short circuit current, 1.67 ampere, what we calculated. This is the R Thevenin, 21.43 ohm, what we calculated now. So this is the load terminal, 15 ohm. So our aim is to find the voltage, the aim is to find the current flowing through this 15 ohm resistor. Current flowing through 50 ohm resistor can be calculated by the current divider rule, right? So I15 means current through the 15 ohm resistor equal to the total resistance, the total current 1.67 ampere into the resistance in the another network, other arm, that is 21.43 divided by total resistance 21.43 plus 15. In current divider rule, the total current multiplied by other branch resistance. Voltage divider rule means total voltage multiplied by same branch resistance. It is current means opposite. So that 1.67 into 21.43 divided by adding these two, 36.43. That is equal to 0.982 ampere. So current flowing through the 15 ohm resistor. What is our requirement? To find the question is to find the current flowing through 50 ohm resistor is 0.982 ampere. So from this value we can find the voltage across. V equal to I into R. I is 0.928 ampere, what we calculated now, into resistance 15 ohm, so 14.73 voltage. The voltage is not asked, but we can able to find the voltage also, right? So in this problem, the given network is converted into Norton equivalent circuit, that is current source in parallel with the R Thevenin. Thereafter the load terminal is connected, so the circuit becomes simplified. The complicated circuit becomes simplified with one current source and two resistor. The current flowing through this resistor is a requirement that can be calculated by current divider rule. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.